Hi folks, here's your walkthrough for your Learning Task 3.1 on solar power. Hopefully you've had a chance to look this over. I've had some questions, so if you are not understanding it, you are not alone. For this activity, you're going to repeat the same task multiple times, and there are 3 different ways to do this. You are going to download this solar power spreadsheet. When you do that, make sure you are opening it up in an Excel or a Google Sheets, something that has the power to open it fully. So here we go. Here is what I have downloaded it previously. And what you can see is there's 3 tabs at the bottom: table of values, calculations, and a graph. So there's lots of things already in here. What they have told you is that there are mistakes on all 3 of them. Table of values. Let's go back to the lesson. Here we go. So the lesson that we had right before this, I'm going to scroll up, 3.1 energy conversions at the end of action, and talked about a solar power module. You can see the information here. And they did summarize it for you, saying that 25 degrees Celsius is the perfect temperature. Even 1 degree off, so they were not so clear, so hopefully I'm clarifying. 1 degree off, either higher or lower than 25 degrees Celsius, there is a reduction, 0.35%, which as a fraction, here it is worked out here, and they do a calculation. So for every 25 degrees Celsius, this solar panel would make 370 watts of power. But of course, if it's 1 degree off, it is making 1.3 watts less. So they did an example at 30 degrees Celsius. Please count with me. The difference between 25 to 30 degrees Celsius is 5 degrees. So that's where this 5 is coming in right here, equals 370 watts minus, and then they're multiplying that change, this 1.3 watts, by 5 degrees difference in Celsius. So they've done that first here in brackets. So 5 times 1.3 is 6.5 watts. Get out a calculator. You can do it paper and pencil, or do it on your computer. And you can certainly find out, because you have to go up and above 25 degrees Celsius. So for 30 degrees Celsius, they're actually telling you what this difference is. So 363.5 watts is how much power that solar panel would make. So we can see it's from the original, at the best, 370 watts, it is down to 363. Okay, so let's jump back over to our Excel spreadsheet. The very first one, I expect everyone to be able to do this. So we started at perfect 25 degrees Celsius. So if we go up or down, you should be going less 1.3 watts. Okay, as I do this, it's a little coding thing for me to put in a number. I just put in a little apostrophe, and then anything I write in there is just going to show up. It prevents it from writing code. If you wanted to write code, generally you start the box and you put in an equal sign, and then it starts telling us various codes that we could do. We could do various things that are set up here. We don't need to do this yet. So at the very least, as you do this, 23 degrees, it's off by 2 Celsius. At 27 degrees, it's off by 2 Celsius as well. So you're going to take that original 370 and you can do these calculations. So hopefully this visual is helping. This is off by 4, and you can see how many times you need to subtract that number. So I don't have the numbers here. That is your work to do. Well, here we go. Bear with me. Here's the last set. So from here, you should be able to calculate with your calculator all the differences. So 370 should be your largest number, and it should be the lowest at 30, and it should be the lowest again at 20. Please make a note, anytime your number does not match what is here in the cell, you have found a mistake. I'm going to jump back to our lesson. over here. And as you go through this, they're telling you that there are 3 or more mistakes for each of those tabs. Look at this discussion. What mistakes did you find? Describe each mistake. Provide the debugged code, which means find the answer. Tell me how you did it. So that's the first tab. Once you have that first tab using that table of values over here, table of values, you should have correct numbers. Keep coming back to this one. Refer to it as the correct answers, because the next tab in calculations, you know what the right answer is. However, once we move away from 25 degrees and we move up, I have highlighted 371.3. Please look up here. This is the formula that has made that calculation to get that number. Now that I've highlighted it up here, we no longer see the final answer. We're seeing the code. When you see an equal sign in a cell, it means that a formula will happen. The B11 refers to the cell that it's grabbing the information from. Column B, cell 11, here it is. So that first formula, it equals the number that's in cell B11 plus 1.295. I don't know about you, but if I go back to our lesson, once again, we're coming back up here. The number that you've been told to work with is 1.3. So you can certainly change this to 1.3. So it's saying take the number B11 and add 1.295. Do you see any mistakes there? If you do, you go in and you fix it. Okay, so I'm not fixing it down here. I am putting my cursor up in this area here, 1.3. And I'm going to hit enter, and there we go. And now things have changed. Here's a quick hint. There's more than one error there. It wasn't just the 1.295. So fix the other mistake that you see, and then check every, whoops, there you go. It's so easy to hit escape to get out of there. It's so easy. Once you have the correct formula, then to verify, do you have the same thing moving forward? Okay, and then do the same going the opposite direction. From your calculation, so they've input this formula here for you, that would be done. Hopefully your answers are going to match the answers you have in your table of values. Last but not least, your graph. They have grabbed, from what I can see, when this was created, they grabbed calculations to fill this out. But if you see the number sign and REF exclamation point, they're saying something is wrong. Your reference cell is not right. Let me go back to calculations one more time. And remember when we had highlighted at 26 degrees this number, the reference cell it's talking to about is that B11. So whatever is happening over here on the graph tab, here, whatever cell it's referring to, it's giving it some sort of circular code. It's grabbing it from a wrong cell. It cannot calculate it. So see about fixing one of those reference cells and see what happens. All you need to do is make sure your numbers and your formula, so you're using both your table of values and your calculations to make sure you have the right calculations here. You do not have to touch the graph. It will plot your numbers for you. Once you've completed all 3 of those, once again, you got to head back to your assignment here and answer questions 2 to 5. So hopefully as you go through and you fix it, you're making a list, perhaps a table of screenshots, and then how you debug it would be a good way to answer number 1. And then they want your opinion and thought. What is the most efficient way to find these answers? If you had small values, so what you did, for instance, changes of up to 5 degrees, which approach worked best for you? But say I ask you also to do it for 65 degrees. Which one would you pick and why? And then, of course, number 5 is a bit of a repetition of 3 and 4. You tell me what worked best for you. When you're done, submit. Hopefully this video was helpful. Let me know if you need any further clarification, and I'd be happy to add.